Imagine a thread so thin it's almost invisible. In normal light, you might not even notice it. But if you try to pull that thread apart, you discover something astonishing. Pound for pound, it can be stronger than steel. If a flying insect crashes into it at high speed, that tiny thread can stop it instantly. And when scientists compare its strength per weight, this material can even outperform Kevlar, the same stuff used in bulletproof vests. What makes this even more incredible is that this material isn't made in a laboratory. It isn't produced in giant factories or designed by engineers. Instead, it's created by a small creature most of us have seen at least once in our lives, a spider. For hundreds of millions of years, spiders have been producing one of the most extraordinary biological materials on Earth. We call it spider silk. At first glance, a spider web looks fragile and delicate. A light touch or a strong breeze can easily destroy it, but that appearance is deceiving. At the material level, spider silk is one of the toughest and most flexible fibers ever discovered in nature. A strand of spider silk can be many times thinner than a human hair, yet it can withstand remarkable amounts of force. When scientists compare materials by weight, spider silk can be up to 5 times stronger than steel. But what fascinates researchers even more than its strength is how it's made. A spider doesn't have factories, furnaces, or industrial machinery. Everything happens inside its tiny body. Inside a spider are special organs known as silk glands, which produce a liquid protein solution. In this state, the material looks like an ordinary biological fluid. But as the liquid travels through an incredibly narrow system of microscopic tubes, something remarkable begins to happen. The pressure changes, the acidity level shifts, and the protein molecules begin to reorganize themselves. By the time the liquid exits the spider's body through tiny openings called spinnerets, it instantly solidifies into an incredibly strong fiber. In other words, the spider is performing a sophisticated form of nanomaterial manufacturing, and it does all of this at room temperature. For us humans, creating advanced materials often requires enormous energy, extreme heat, and complex machinery. Yet the spider accomplishes something similar effortlessly, using nothing more than biological chemistry. Even more surprising is the fact that a spider doesn't produce just one kind of silk. Many species can create up to 7 different types, each with its own unique properties and purpose. Some silk is extremely strong and forms the structural frame of the web. Some is highly elastic and acts like a shock absorber when prey collides with it. Some silk is sticky, designed specifically to trap insects. Other types are soft and protective, used to wrap eggs and shield the next generation. In effect, a spider carries an entire biological materials laboratory inside its body. But the question remains, why is spider silk so strong? The answer lies deep within its molecular structure. Spider silk is made from long chains of proteins. Inside each fiber, these protein chains organize themselves into 2 main regions. One region forms tightly packed crystalline structures that provide strength. The other region remains softer and more flexible. These flexible sections allow the fiber to stretch without breaking. This combination of rigid crystals and flexible chains creates a remarkable balance between strength and elasticity. If you pull a steel wire too hard, it will snap suddenly, but spider silk behaves differently. Instead of breaking immediately, it stretches. In some cases, it can extend to nearly twice its original length before finally snapping. This ability allows the silk to absorb enormous amounts of energy. That's why a delicate spider web can stop a fast-moving insect without tearing apart. The web behaves almost like a natural shock-absorbing net, spreading the energy of the impact throughout the entire structure. For scientists studying advanced materials, this is close to a perfect design. Naturally, researchers began asking an important question: could we humans recreate spider silk? If we could manufacture it on a large scale, it could transform multiple industries. Imagine ultralight protective armor, cables stronger than steel yet far lighter, and medical materials that safely interact with the human body. The possibilities are almost endless, from aerospace technology to everyday consumer goods. But there was a major problem. Farming spiders for silk is nearly impossible. Unlike silkworms, spiders are predators. They're territorial and often cannibalistic. If you put thousands of spiders together, they tend to fight and eat one another. This makes any kind of large-scale spider farm extremely impractical. So scientists began searching for another solution. Instead of raising spiders, they tried copying the genes responsible for producing spider silk. Those genes could then be inserted into other organisms. Some laboratories used bacteria, others used yeast. And in one particularly unusual experiment, scientists turned to goats. Researchers successfully created genetically modified goats that produce spider silk proteins in their milk. After the milk was collected, the silk proteins could be extracted and spun into fibers. It might sound like something from science fiction, but it represents a major breakthrough in biomaterials research. Today, biotechnology companies around the world are continuing to study spider silk. Some have already developed synthetic fibers with properties very similar to the natural material. These fibers are now being tested in many different fields. In medicine, spider silk may one day be used as ultra-strong surgical sutures that are both durable and biocompatible. In tissue engineering, it could serve as a scaffold where living cells can grow and regenerate damaged tissue. In textiles, spider silk fabrics could create clothing that's incredibly strong, lightweight, and environmentally friendly. And in the future, materials inspired by spider silk may even play a role in building spacecraft or advanced transportation systems. But perhaps the most remarkable part of this story is something simple. Humanity has spent decades trying to understand the secret of spider silk. Yet nature perfected this design hundreds of millions of years ago. Every spider web you see in a garden, in a forest, or quietly stretching across a corner of a room is a masterpiece of biological engineering. It's a reminder that nature is not just the environment we live in. It's also an immense library of solutions to engineering challenges that humans are only beginning to understand. And spider silk is just one example. Across the natural world, countless organisms have evolved structures, materials, and systems that surpass much of our current technology, which means the next revolutionary invention won't come from a laboratory. It might already exist in nature, waiting for us to discover it. So the next time sunlight reveals a delicate spider web in the morning air, remember that you are looking at one of the most extraordinary materials ever created, a perfect blueprint from nature. Thanks for watching, and if you enjoyed this look into the wonders of the natural world, don't forget to like and subscribe for more.